This is the Wright Flyer, the plane that taught humanity how to fly. The Wright Flyer was the product of 4 years of rigorous and relentless research and invention. Every piece was a solution to a problem no one else could solve. In December 1903, this masterpiece allowed two brothers from Ohio to achieve what generations had only dreamed of: the first sustained, controlled flight of a powered, heavier-than-air machine. In this video, we'll break down the Flyer part by part: its wings, engine, propellers, and controls, to show how they all work together to create lift, thrust, and stability. You'll see the problems the Wright brothers faced, the ingenious solutions they invented, and how this fragile machine became the first aircraft that could truly be flown on purpose. Let's go. The Wright Flyer was an experimental biplane designed and built by Wilbur and Orville Wright. It combined lightweight construction with innovative control systems, making it the first aircraft that could be flown deliberately rather than just glided. Now let's meet the Flyer's parts. The Flyer had two wings stacked one above the other, forming the classic biplane shape. Stretching about 40 feet across, each wing measured roughly 6 feet 6 inches from front to back. Together, they covered an area of 510 square feet. That was just enough to lift the Flyer's weight of around 605 pounds into the air. The two wings were connected by struts and wires. These gave structural strength while keeping the wings light. This biplane design also reduced wingspan length, making the aircraft easier to handle. The Wright Flyer's wing frames were built from spruce and ash wood for the frame, chosen for strength and lightness, and then covered with finely woven cotton fabric to create a smooth surface for airflow. The wings featured positive camber, meaning curved upper surface, to generate lift. You see, the Wright brothers discovered through their wind tunnel experiments that a curved wing surface generated more lift than a flat one. So they shifted the highest point of the curve closer to the front, called the leading edge of the wing. This curvature accelerated airflow over the top, causing air to move faster over the top than underneath. The pressure difference creates an upward force strong enough to lift the aircraft even at lower speeds, which was crucial because their engine wasn't powerful enough to make the Flyer move very fast. The Wright brothers couldn't find a commercially available engine light enough for flight as at that time, so with their mechanic Charlie Taylor, they built one themselves in just 6 weeks. It was constructed from aluminum crankcase, which was very rare back then in 1903, and it reduced weight significantly. The whole engine weighed about 180 pounds, which was light enough for flight. The engine was a 4-cylinder internal combustion engine. Just like modern car engines, it worked by burning fuel mixed with air inside cylinders. The burning fuel expanded rapidly, pushing the pistons down. The motion created by the upward and downward movement of the piston was converted into rotary power to spin the crankshaft. The gasoline fuel was stored in a small tank mounted on the wing strut. It flowed into the engine by gravity feed, so no fuel pump was needed. To keep the engine running, a magneto spun with the crankshaft, generating electricity for the ignition system. A flywheel smoothed out the pulses of the cylinders, keeping the engine steady. The crankshaft drove two wooden propellers mounted at the rear of the wings using bicycle-style chains and sprockets. The two wooden propellers were each about 8.5 feet long. The propellers were carved from multiple layers of spruce wood, glued together rather than a single piece. This design reduced the risk of the propeller twisting or splitting under stress. Each blade also had curvature and an angle of attack. The design was optimized to pull enough air backward and generate forward thrust. Notice how one chain was crossed so the propellers could spin in opposite directions. Why was that? They made the propellers spin in opposite directions, one clockwise and the other counterclockwise, to cancel out torque forces that would have twisted the Flyer uncontrollably due to a phenomenon known as propeller torque effect. If both propellers had spun the same way, they would have created a deadly torque effect, causing the Flyer to twist violently in the opposite direction. By making the propellers spin in opposite directions, the torque canceled out each other, leaving only pure thrust and a stable flight. For a smooth takeoff, the Wright brothers built a 60-foot wooden rail that kept the flyer aligned straight during takeoff, preventing it from veering off course. The pilot lay prone on the lower wing to reduce drag and control the aircraft. As soon as the engine starts and the propellers began to spin, the flyer moved forward along its wooden launch rail. With every second, it gained more speed. When the wings produced enough lift to overcome the pull of gravity, the machine rose gently off its wheeled dolly and climbed into the air. Once the flyer rose into the air, speed and lift alone weren't enough. To stay aloft, it needed control, the ability to climb, turn, and balance. The Wrights solved this with 3 systems: the elevator for pitch, wing warping for roll, and the rudder for yaw. How did they achieve this? Well, to control pitch, the pilot used a hand lever positioned beside him. Pulling the lever raised the front canard, lifting the nose upward, while pushing it lowered the canard, causing the nose to dip downward. This simple mechanism gave the pilot direct authority over climb and descent. To control roll, the brothers invented wing warping, a system that twisted the wingtips in opposite directions, which was controlled by the hip cradle. When the pilot shifts his hips left or right, he pulled on cables connected to the wings. As shown here, the red cable pulls the trailing edge of the wing tip downward. At the same time, tension loosens slightly on the blue cable, allowing the leading edge to rise slightly. The opposite of this effect occurs on the right side of the wing, creating a twisting motion. This twisting motion changes the angle of the wingtips on both sides, causing one wing's angle of attack to increase and generate more lift, while the other decreased and generates less lift. The result was a smooth roll, allowing the flyer to bank into turns. But there was a problem posed by this method. The increase in angle of attack of one wingtip also led to increase in drag, while the decrease in the angle of the other wing led to decrease in drag, causing a drag imbalance that pulled the nose the wrong way. This mismatch is called adverse yaw. To solve this problem, the Wrights tied the rudder to the wing warping system so that the rudder can tilt in the opposite direction, to create a yaw that will cancel out the adverse yaw, keeping every turn smooth and coordinated. With all these problems solved, in December 17, 1903, the Wright brothers achieved 4 successful flights with the flyer at Kitty Hawk, North Carolina. The longest of these lasted 59 seconds and carried Wilbur 852 feet across the sand. Those short flights marked the first sustained, controlled, powered flights in history, and in that moment, the world of aviation expanded forever. Many of the principles used by the Wright brother for flight control are still in use till today. Wing warping by twisting the wings has now been replaced by ailerons. Rudder control has now been replaced by advanced vertical stabilizers. Counter-rotating propellers are often employed by modern aircraft to maintain balanced flight and reduce torque effects, especially in multi-engine configurations. Thanks for watching. Be sure to subscribe so you don't miss future videos. Share your thoughts or questions in the comments.